In this video, video number 2 of how to build Flappy Bird in Unity, we will be talking about how to make the infinite pipe generation. So, if you recall, in our last video, we got the bird flapping up and down. So, we click the spacebar, or if we click the mouse button, the bird flaps up and down. Alright. In this video, we are going to actually be making the pipes, because right now we don't actually have a game yet. We just have a bird that flaps up and down. So, first thing we're going to do is right-click, create empty, and we're going to call this pipe. And we're going to set it to 0, 0. And we created a empty game object because this won't have any components except for a transform component, because we are going to add components, we're going to add game objects inside of it. So it's going to act, so this empty game object is going to act as a folder of sorts. You'll see what I mean in a second. If we right click that object and go create 2D object sprite square, the square gets added underneath our pipe. So when we move our pipe, the square also moves. The square is a child of our pipe. So we can use our rect tool to scale it up. I'm going to set it to scale of 5 and put the position at 2. Sorry, yeah. Okay, now, yeah, I'm gonna keep it at 5. No, yeah. 4, I think. Yeah, 4. Okay. Then we're going to duplicate that and change the position to -4 at the Y. So now we have something vaguely resembling Flappy Bird pipes. And these squares are children of this empty pipe object. This empty pipe object acts like a folder for these two things. I'm not going to rename them, and I'm going to change their color to be green for now. Okay. Yeah, very nice. Now, to actually make the bird collide with our pipes, we're going to have to add a square collider for both of these. In order to select both of these, you can click them and then hold Shift and click the other one, which allows you to change both of them at once. So you want to press Add Component and press Box Collider 2D. This will add a box collider to both these squares, so the bird will be able to collide with these pipes. Alright, so that's our pipe game object, and since these two squares are underneath it are children of the pipe, when we move the pipe, they move as well, which is perfect. Now, we can go click this pipe and drag it into our prefabs folder. And then we can delete this in the hierarchy. And then click save. So now we have a prefab of a pipe. And a prefab is just a pre-made object that can be used multiple times. So I can drag multiple pipes into our scene. Okay. Now we actually need to get the pipe spawning. So we're going to right click again, create empty, set it to Y of 0 and X of 20. And we're going to call this pipe spawner. And we made it an empty game object because we don't need it to have any additional components. We just needed to have a position, and that's really it. And we'll add a script to it later on. So in our scripts folder, we can right click again, create model behavior script, and then we can call that script pipe spawner. Double click that to open it in Visual Studio. Okay. Before we start coding, I will explain what we're going to do. So we have our pipe spawner at 20 for x and y0. So it's right over here. What we're going to do is we're going to spawn a pipe at this pipe spawner and then continually move it until it reaches a certain distance away from our pipe spawner. And then we're going to spawn another pipe, have that move a certain distance, and then once it reaches that distance, we're going to spawn another pipe, and it'll keep going on and on and on, and these pipes will also move. Alright, also, let's drag our pipe spawner script onto our pipe spawner object. So our pipe spawner empty game object should just have our transform component and our pipe spawner script, and that's it. Because again, in order to call code from a script, you need to have that script on an object. So if you just need a script and it doesn't really control any game object itself, you can just create an empty game object and place that script on it. So we have our pipe spawner object that holds our pipe spawner script. Okay, inside the script, we have our default Unity script. We have the class pipe spawner and the start and update methods. And we discussed what these were in the last video. The start method gets called once after the game starts. So once you click play, the start method gets called, and then every single frame after that, the update method gets called. So the first thing we're going to do is create a variable that holds our pipe prefab. So public, which will allow us to see a spot for it in the inspector. Public game object, because our pipe is a game object. Anything that we can create in Unity is a game object. Anything we can manipulate in Unity is a game object. And we're just going to call this pipe. Cool. And then if we go back into Unity and we click pipe spawner, we have our pipe prefab. We have our pipe variable here that has a little slot for a game object. We can drag our pipe prefab into that slot. Cool. Then, if we go back into our script, we can create a new method or function called create pipe. So we're going to make a void because our function isn't returning anything, and we're just going to call it create pipe. So whenever we call this method or we call this function, a pipe will be created. So we're going to go and create a variable, game object, new pipe equals to instantiate, and instantiate just creates an instance, or it just creates a new instance of the prefab, of a given prefab. So we're going to instantiate pipe, which will create a new instance of our pipe prefab. So it'll create it in the scene. we need to pass in our position. So we want it to be created wherever our pipe spawner is. So since our script that we're in right now is on the pipe spawner, we can just go transform dot position. Cool. And then quaternion dot identity. Don't worry too much about what this means. This is just the rotation. Quaternion dot identity just means the normal rotation of our object. Cool. However, that's really not everything we need. We also need a couple of other variables. We can make this private because we don't need to see it in the inspector. We need a list, and you want to import the system.collections.generic package, which will give you the list data type. We want to create a list of game objects. We're going to call this pipes. And this will be our list of all the pipes in the scene. So, in our start method, because the start method is used for initialization, we're going to go pipes is equal to new list of game object. Cool. So now, in our create pipe method, we can add new pipe to our pipes. Now we also need to keep track of our last created pipe, because remember, we need to create a new pipe whenever the last created pipe reaches a certain distance away from our pipe spawner. So we're going to go private game object last created pipe, and this will give us a variable to hold our last created pipe, which we can use to check if we should create a new pipe or not. So we can set, whenever we create a new pipe, we can set our last created pipe to our new pipe that we just created. And that should be it. Let's create a new pipe whenever we start the game. So create pipe. Okay, let's go back into Unity and test this. As you can see, a pipe has just been created. Very cool. Now let's move the pipes. So in update, because this will happen every single frame, let's loop through the list of pipes and move every single pipe. So for each game object, P in pipes, we're going to go P dot transform dot translate moves things. We're going to move it vector 3 dot left times, let's create a new variable. Let's make it public so we can edit it. Public float to make it a decimal. Pipe speed. So vector 3 dot left times pipe speed times time dot delta time. And okay, that's good. So what we're doing here is for each game object P in pipes, we're going to transform.translate P to the left at pipe speed and at time to delta time, which allows things to have the same frame rate across different devices. So that's why you put that. So vector 3 dot left times pipe speed times time dot delta time moves our pipe to the left at pipe speed. That's what that does. And as you notice, we did something dot transform here, but nothing dot transform here. The reason why we didn't do anything before this transform is because just writing transform references the transform on the object the script is on, and calling something dot transform references the transform on this thing. So we are referencing the transform on game object P, something in our pipes. So if we go into Unity, we should see the pipe speed thing in our pipe spawner. Let's make it 15. When we click play, our pipe zooms to the left. So let's maybe make it a bit slower, maybe like 7. Okay, that's good speed, 7. Cool. That's only one pipe. We need to have more pipes, obviously. We have a very boring game. So let's say we have a pipe that gets spawned right here. We're going to move it. Let's say it reaches a distance of like 5 away from our pipe spawner. We are going to create a new pipe. So in our update, we can go if vector 2 dot distance, actually, let's change this here to vector 2 dot left. And again, sorry, I don't think I explained this. A vector 2 is x comma y. Sorry, it's like an x comma y. It's like a position. A vector 3 is like a position in 3D space, so it's like x, y, and then something like z. Since we're in 2D, we can just use vector 2 because we just need x and y. So yeah. So if vector 2 dot distance, this will calculate the distance formula. So if the distance between last created pipe dot transform dot position and transform dot position and the position of, okay, no, never mind, we need to have this vector 3. Do we? Vector 2? I don't know. So if the distance between last created pipe and our transform, which is the transform of the object the script is on, which is the pipe spawner, if it's greater than, let's say, 5, we're going to create pipe. So if vector 2 dot distance, this calls the distance formula on two vector 2's. The distance between last created pipe dot transform dot position, the position of our last created pipe, and the transform dot position, the position of our pipe spawner. If that distance is greater than 5, we are going to create a new pipe. Great. As you can see, multiple pipes are now spawning. However, they're all at the exact same height, and they're going on forever, which is not good. So let's fix both those problems. First things first, I'm going to set this pipe speed to 4. Maybe that'll be a little slower, because it's still a bit fast. Okay, I think that's fine. First things first, let's create them at random heights. So let's create a new vector2, and we're going to call this pose for position. This is just going to be a variable that'll hold a vector2 position, because we're not going to be using the transform.position anymore, because we want to create it at a different height every single time. So vector2.pose equals to new vector2. The x will be the same, so transform.position.x. So the x will be the same as the x position of our pipe spawner, but the height will be random. We're going to go random dot range. The height, let's do it from -2 to 2. So the reason why we put 3 there is because random.range is exclusive, so it's a minimum inclusive, so it's going to include -2, but it won't include this number here. So if we want to do 2, we're going to have to do 2 plus 1. It'll always go from -2 to whatever number. It'll always go from the number over here to the number over here minus 1. So that's why we make it 1 more than what we actually want. So it'll go from -2 to 2. So instead of being created at position 0, as it was, because if you look here, our pipe spawner is at y0. Instead of being created at y0 every single time, it'll be created at a random range from -2 to 2. So instead of transform.position, we can replace that with pose. So now, if we go back into Unity and we click play, yep, they get created at a random height. It's pretty cool. We might want to go into our pipe spawner by double clicking the pipe in the prefab and making the height something like 7, and changing the position to something like 5, and -5 for the lower one. That's good. So now the pipes are a bit higher, so it won't look weird if we create them a little low. Let's try this again. Alright, great. Cool. So we have our pipes spawning. However, we have another issue that we can talk about. We have a lot of pipes being created. If we change the pipe speed, for example, so many pipes will be created. That's not good. So let's delete them after a while. Okay. So what we're going to do is, as it's looping through pipes, if p dot transform dot position dot x is less than or equal to -20, we do less than or equal to because there's a chance that this line of code gets called when it's at like -20.1 or something like that. So less than or equal to -20. If p.transform.position.x is less than or equal to -20, we're going to destroy p. Destroy just destroys any object. So, cool. Let's see if this works. Once it reaches about here, our pipe should be destroyed. And it doesn't. And there's a reason why. There's an error. Because even when we destroy an object, it's still in our list. It's just in our list as null. It's in our list as nothing. And you can't call code, you can't transform to translate nothing. So we want to do an if statement. If p is equal to null, so if p happens to be null, we are just going to pipes dot remove p. So if p.transformAtPosition dot x is less than or equal to 20, we're going to destroy p, but that still leaves a null game object in our list. The game object gets destroyed, but the object is still in our list, but now as nothing. And we can't do operations on nothing. So if, as we're iterating, we hit something in our list that is nothing, we're going to remove it. And now this should work. And it does not. And that is because we are still calling that there's still a chance that we are calling this code on something null, because this gets executed last. Or there's still a chance that as it's looping, because this is still a loop, so there's a chance that something got destroyed, but it didn't get deleted. That's what it is. So if p is not equals to null, then we can call all the code. And that should work. As you can see, it's working, but we're getting another error. And this error is that we're constantly deleting things from pipes, and then also adding things to pipes, and then doing things in that list, which you can't really do. So you just want to go pipes dot to list. So this just works on a copy of pipes, so we won't get that error anymore, because Unity doesn't like when we do things to a list and add and remove things from a list. Unity doesn't like when we do that, so we want to work on a copy every single frame. So now, speed this up to see. Yep, we'll always have a limited amount of pipes in our scene. So we can run this game at like super high speeds, and it'll still only have like 1, 2, 3, 4, 5, 6, 7. An average of 7 pipes on our screen at once. Don't do this. don't make it that fast. Yeah. So this is your code. I think we can make it a bit neater. I'm going to try to do that. But I'm also going to say, as a rule of thumb, whenever you do a for each loop, you should always put if p is not equal to null, just to be safe. You do always want to check if what you're working on is not nothing, because you can't work on nothing, so it's just always safe, even if you don't think you will ever do this. It's just always safe to check if you're working on something. You want to work on something, so p is not equal to, and not equal to is exclamation point equals. And to check if something equals to something, you do equal equals. And to set something equal to something, you just put the normal equals. Okay, so you always want to check if what you're working on is actually something or not null. I think we can just put pipes dot remove just in this if statement, and we can remove this. That should work. Save. That should simplify things, and that should work. Yeah, that works. Okay. Yeah, so we can simplify that code. We can just write it as for each game object P in pipes.toList, which creates a copy of a list every single frame, because Unity doesn't like it when we do things to a list that's being added to or subtracted to. We're going to check, and I don't think you really need that check since we added pipes in here, but it's still always good to include this. You want to check if P, because we're looping, so we're going for each game object P. So if P is not equal to null, if P is actually something, then we can translate it to the left at pipe speed, and if its position is less than or equal to -20, we're going to destroy the game object and then remove that null object from your pipes list, because even if you destroy P will become null, and there'll still be a null object in your list, and you can't, you don't want that. That'll still be stuff in a list. That'll be a very big list. You still want there to be as many items in your list as there are in your scene. So you just want to remove any null objects. That's what you do. Pipes that remove right after you destroy it, because that removes the null object that you created when you destroyed P. And if the distance between our last created pipe and the pipe spawner transform gives us the transform of the object the script is on, which is our pipe spawner. So if the distance between the last created pipe.transform.position and transform.position, or the pipe spawner.transform.position, is greater than 5, we're going to create a new pipe. We're going to create a new pipe. And then we have our create pipes method, which just first it creates a variable called position or pose of type vector2. Vector2 is just a point, a 2D point, and it'll have the x value that's the same as our pipe spawner, so 20, and it'll be created with a y from either being -2 all the way to 2, because it is random.range, which is excluding the maximum number, so it's from -2 to not including 3, so -2 to 2. And then game object new pipe is equal to instantiate. We're creating a pipe. We're creating a new instance of our pipe prefab at our position with a normal quaternion rotation. You can ignore this part. You don't need to worry about what it means. We just put this when you want it to be at its default rotation. Then you set the last created pipe is equal to new pipe, and then we add pipes. Then we add the new pipe to pipes, and that's all we did here. So if we go into our game, we can now play a game of Flappy Bird. Now there are still some things wrong with it. As you can see, the pipes push the bird away. But that is something we will discuss in our next video about just finishing up some of the code. We're going to talk about restarting the game and adding points and stuff. So I will see you in the next video.